Hi, hello everyone. Welcome back to my channel. So previously we are studying cantilever beam subjected to uniform distributing load. So today we are going to learn cantilever beam with subjected to uniformly varying loads. That means in last class we are studied about uniformly distributed load. So that means load is acting and element is uniformly distributed. But now here the load is varying from point to point. So now consider this is a uniform varying load in that see here load is how much here. So when compared to here there is a increment is load. So when compared to here there is increment, that means varying load is varying here. So this is, so for that we want to draw the shear force and bending moment how it is. So for that first of all this is a diagram, that means is a cantilever beam, that means one end is fixed at another end is free end. At that we are acting a load, that is uniform varying load acting. So for that we want to draw the shear force and bending moment diagram. For that first of all we want to consider the notations A, B, C like that. After that we want to give these notations. After that first of all consider the portion CB and then AC. So if we consider portion CB, for that we want to divide a section XX. So it should be in between the CB we want to divide a section XX. Next, how we are dividing section XX? So from the free end to the section XS, how much distance means X distance. So how much distance? X distance. See here. See the diagram carefully. From section XX here to the from free end is X distance. Total distance is L. Okay na, understood? And next the load how much, that means load acting is A distance load is acting. So previously also in uniform distributing load also they given how much load acting, how much length is given. So likewise here also. So now portion CB is considered, we want to divide a section of that means section XX. So first of all if we want to know the shear force for that before going to study that we want to know the what is the area of triangle here. So see the shape is how it is in the form of triangle. So what is the triangle area? Half into breadth into height. So half into B means what here? Breadth is this distance, load, that means load distance is A. Height is what here? W, because this load is acting this entire, no, for that this is the height here. So now what is shear force? Shear force is only we will consider only load, not distance. For that here half into base into height. So according to the triangular formula we want to consider the shear force here. Previously that is different, and point load also it is different. So now totally different from those two, this one. So here shear force is half it, that means half into base into H is what? Area of triangle. So now we are going to study only triangle here. For that half is half. Next breadth is what? X. For that before we divided this one into section XX. So then we want to consider this section, this one only. So for that here we want to divide as a, see now. So here 2/3 of portion and here 1/3 of portion. So from this point from ending is 2/3 of distance, and then now we are considering only this element only, that means section XX. How much distance? X distance we are considering this one only, not entire one. So for that here also there is a some it is moving, that means load is acting here at the 2/3 from the free end. So then it is moves to this section XX. What is remaining here? 1/3 of distance is remaining. For that, so this is our shear force is half into base is what? This we are considering only section XX before right hand side only. So distance what? X base, and height is what? Shear force W only. See here W by A. Why we are writing A means load acting this entire A. For that WA. Okay na, understood? And X is X. Understood? Shear force is half into X into WX by A is equals to, that becomes X into X what? X square. That means WX square by 2A. See, we written like this. Next, bending moment. Bending moment is what? Force into distance. We already computed here the force and distance what? X by 3 is the distance. See here, x by 3, that means 1 by 3 is nothing but x by 3. X by 3 is the distance. That becomes minus wx cube. Here x square into x what? X cube by 6a. 2a into 3 what? 6a. It becomes, it is bending moment, force into distance. Force we already force already we are find out here, and then here into distance. If we find out, we get a here. So next we want to substitute this. That will be study in this line we will study in when doing numerical problems at that time. Understood? So now it is waste in problems. While solving a problems, there we can understand carefully. Next, now portion CB completed. Now consider the portion AC. Here AC, in this we want to divide a section XX like this. See, this is very understanding method. So now if we consider section XX here, that means this load entire is a 1 unit, because what is the right hand side? So that entire will act, then this will move. That means load is 2 by third here and here 1 by third. So the load is entirely moving from here to section XX. So how much distance from section XX nunchi free hand to X distance only same. Next, what is the total length is L, that is different. So now what is shear force here? Shear force is also half into base into height only here also. So for the according to that we want to write here half into base. Base is what? A. See here, A is our base. Total load acting base. Total triangle we are considering now. Portion AC key. At that time the portion is this all will come. For that A is the base and height is what? W is a base. See, only W here acting now. So that becomes WA by 2. That means WA by 2, it becomes a shear force. Next, bending moment. Likewise, force into displacement. What is bending moment time? At the time we use a minus sign. In shear force we do not use any minus sign. It is positive, because that all we studied in theory part. So next, bending moment is minus half into base is what? A into W, that is already know. Next, x is what? Distance. That means displacement. No, x minus 2a by 3. How it means 2a? See here, x minus, that means this is a total x minus, we want this one, we want here to this one. At that time total minus this one we know. If we know this minus this, we get our required one. Understood? X minus 2 by 3. So that is here x minus 2 by 3. A is indicate here what means its area triangle. That is a A. Understood? X minus 2a by 3. Understood? Is very important, ma. Then x minus 2 by 3 here. The it will be there 2 by 3 here. Here 1 by 3 here. Understood? 1 by 3 is that means center there is no, here 1 by 3. At the point corner, at that time we will use 2 by 3. It is constant. For wherever the like these problems we get, we want to consider here 2 by 3, here 1 by 3 we will consider. That is the basic one. So now the bending moment is we got it. Next, bending moment at C, where exactly x is equals to a. The same here, C, where x is C. That means bending moment at point C, where exactly x is equals to a. There is no change at all, except to x place we will place a here. Half into a into w in the place of x, a. Why? Because he given where x is equals to a minus 2 by a by 3. So this is a theory problem. Next, we want to draw the shear force. We already know where we get a square and cubic values. At that time we will draw a curve shape. Understood? That means here shear force. Shear force, first of all we want to draw a one axis line. At that one the value is positive here, wx square by 2a. That means here the it is in square? No, for that we want to draw a cubic, that means it's a curve above it, because it is positive. And then portion AC, what is shear force? WA by 2 here. Only no square value, at that time it becomes a straight one, so that is shear force. Now coming to the bending moment, for this one portion CB, what is bending moment is minus WX cube by 6A. The value is in the form of negative, at that time it is a cubic. No, for that is also curve shape. First of all draw a reference line, and from this point to do the x and x's, here we get a negative value in cubic, then becomes as curve shape. And then portion AC, what is the bending moment here? That means x minus 2a by 3, that means this whole, at that time it is in not in square or cubic, so this is a simple straight line. So this is the bending moment diagram. So this is the derivation part, and next class we will discuss the problems while simply that means cantilever with point load, uniform distributed load and uniform varying load. In that we will discuss problems. So thank you for watching this video. Please subscribe my channel, like, share and comment. So if you have any doubts, ask in commentary section, I will clarify you. Thank you.